Hello everyone. So today, we are going to see Google Kickstart 2022 Round A solutions. So it's better we will start with the first problem. So Barbara says the problem is called speed typing. So Barbara is a speed typer. In order to check his typing speed, she performs of speed test given a string of I. She is supported to type. While Barbara is typing, she might make some mistakes such as pressing the wrong keys or typing some speed and so she does not want to spend additional time correcting mistakes, so she will use type. Until she finishes this speech, the options will produce a name to get Wait. So what it is like going to say is they are given a string of I. In that we need to make a string of p. So we need to compare uh, and they are also given there is no time to delete some words okay, so ask her to type important words. She does not want to spend additional time in correcting mistakes. So what she was doing, typing, she doesn't want to correct any mistakes. So after that, she has been completing. So if she now she wondered how many extra letters she needs to delete in order to get I from P, if it is possible. So we need to delete some letters from P to get I from P to get I. So what is the minimum number of letters that minimum number of letters that we need to delete from P to get I. So first, I think this first string is of for each input T number of test cases. First line is of I input and second line is of P input. So we need to from P we need to delete some letters to get I. So we'll compare with A by A. If it is possible. Here in P we have 4 B's and 1 C. So but in in I we have only 5 B. So C cannot be implemented. We are supposed to be only delete. The only possible operation we can do is we can delete some characters from I to make this P. So sorry. Yes. So we can have this thing. So in this first case, we can delete one A to match this two cases. In the second case, we can't add a C, and in place of B we can't add C. So this is impossible. So it is really impossible. In the second case, I love coding. So I two I's are there and two L's are there. So we need to remove one I, one L. So removing operation it can be done. So in next case, right, so we'll compare. So we can add this, remove this K1. So, and then we need to, we should have a capital I, but we are having a small I, so we can't change this kind of indentations, consequentalities. So in this case, it is becoming false. So and then F should be in caps, but the F we are having is F, a small f. So in this case, it is impossible to have this changes. So we will return impossible. So how my code starts is um, we'll have a s of string impossible. So we'll get I and P. So what we'll do, we'll just compare if Li is greater than L. So Li is the length of I and P is length of P. If Li is greater than B, count equal to zeros or that is if let's say I a length of I is always greater than P, which means we obviously have every element inside this P inside I. So we don't need to do any operations. Obviously we have many operations, many count extras. So we return this count equal to zero as such. And then in this case, right? So if I is less than or equal to P, so we need to compare with each and every string. So what we'll do, we'll keep 2 pointers like I, j questions, and then we will compare with a of I equal to equal j. So if it both are equal, like let's say like I equal to I, so we'll increment I and j by 1 1, and we will also like increment this count plus equal to 1. Okay, so else case, like if L not equal to I, so what we'll do, we will increment this j, that is this portion, right? So P's portion is for j, so we'll increment this P's portion and answer plus me. That is the count, like we number of count we need to remove it. So if we will check like this string, right? So number of equal strings, that is count. So that is equal to Li, that is from P, which and all it will be like equal. So count will be like giving. So how many equal letters we have in P? So we'll start with this some cases or something. Okay, so let's say in a case, so we have I. It's better to so what to do. So we'll have something like this. So in this case, like what we will do, we'll have this I. So if this both I equal to 0, so we'll increment. So count is for this P. So this count is for this P. So answer is like, so we'll come to answer. So answer is number of elements to be removed. Number of elements to be removed. So if I equal to 1, so we'll count it. So it is not equal, so we'll just leave it and increment this j. So LL it is equal, so we'll go with LL. So count here 1, and O it is equal, so count 1. VV it is equal, so count plus equal to 1. So EE it is 1. CE it is 1. So OE O it is 1. So DD 1, I and G, so I'll increment all by 1. So I'll count this number of counts that is incremented, right? 1, 2, 3, 4, 5, 6, 10, 11. So 12. So there is 3, 6, 9, 11. So we have approximately 11 letters. So in this above also, like we have a 3, 6, 9, and 11. So what we'll be doing is we'll be comparing with Li. So list if count length of count that is found in PE, it is equal to a length of I. So we'll increment by answer equal to answer plus Li minus j. So that is we need to remove answer elements, right? So that depends on LP, like number of total number of LP minus j. That is j is the outer element, right? So this j that is the inmost, right? So LP minus j that becomes a 0. So answer equal to answer. So number of elements that needs to be deleted. So that will be coming like this. So in else case, like we'll be printing the string that is impossible. That's it. It is somewhat like easy problem with a greedy solution. So we move on to the next problem. This is the problem called challenge 9. So this challenge 9 is somewhat of math problem. And it also has a greedy solution. Ada gives a John a positive integer. She challenges him to construct a new number without leading zero. That is multiple of checking exactly. So like they have been given a number n. So we need to make this n as a divisible of 9. So that is we need to insert only one element. That is that should be like after inserting that element should be a minimum possible value, and then it should also be like divisible by 9. So that's what the case is. So what we'll do, like we need to like find first like uh, what element should be like added. So we'll go with the first. So like in every case, like adding or summing or something. So like finding its divisibility test, like we need to get the element, like particular element. So which element should be added in whatever place. So it can be in whatever place. So it is like second case. So in first case, like which element to be added, it is whether it is the 1 or 0 or 2 or 3 or something. So first, which element to be added. So we'll go with that first. We are getting making this n as a string. Sum is 0. So for int I equal to 0. So we are getting that add element. So that add element equal to 9. So that minimum element, right? So we need to have a minimum element. So if that add element equal to 9, so let's say like she is been giving a element called 0. So number called 0. So in that 0, so you need to add 9 for it to be divisible by 9. So that in that case, so you can't add a 0 there. 0 0 sorry. If you are given with 10 or something, so you need to add a 18 or something. So it is already divisible by 9. So you can't add 9 with it. So it is better to add a 0 with it. So what we'll do, we need to find the optimal question that way. Okay. So that is this A element will be giving 9 minus some odd 9. So that will be giving us which element that to be added. And in max case, like we will come converting it to 0. That's it. So and the second case comes with like in which portion we need to add it. So that was a critical point is. So in leading number of 0, so we need to have it in a minimum. Mean like in a if the element is like, let's say in case of 0, right? So we can't have it in a first higher significant bit. So in that case, like the given number and the output number both will be like same. So we need to have it in a place like where after the first element, right? So we are adding it after the zeroth element. So zeroth element, the 0 plus the remaining elements will be like given the say else part of 0. So in else case, like what we'll do, we'll traverse it through the element. So we will find the optimal portion. Let's say like this thing, right? Okay, let's say it for we'll go with first case 45. So in this case, like we need to get a portion in such a way that this element should be like a minimum of that element. So let's say we are given with 5, right? So we will travel to this 5, 0 to a length of element. That is 5. If 5 is greater than int of element, answer equal to that. Then we are adding it in appropriate way. That's it. So else whether like what we'll be doing, we will traverse to the next page. Like we should add the element which should be like in minimum position. So it is for this case. And if flag that is like if flag is 1, so we'll print this s plus a equal to 0. So in this else case, right? So if it is like given to the end path, right? Let's say we have a number called 9999. So this element is something like this. So let's say we have a number called, just for example, right? So I didn't take any number called. So we need to add element of 2. So to make it divisible by 4. So we can't add a 2 here. When then it will be like 42570. That is like literally max. So if we add 2 here also, like it will be like max. If I add 2 here also, it will be like max. So the best case, like it will be like adding 2 in the before. So in this case, like we need to find a portion where, of this x element that should be like this x element should be like whether it should be in a smaller portion. So this function will do that variations, and then we in after that else case, right? So if we have an element something called let's say we are having an element of 8. So in this case, like we need to find a value 8 is greater than 4, right? So 8 is not less than 4. So we'll go over here. 8 is less than 5, no. So 8 is less than 6, no. 8 is less than 7, no. So in our case, like this else loop will break there itself. So in else part, we have if flag equal to 1. So we are adding at the last. That's it. So this case is for 8 here. So the only possible value of adding 8 is the last portion. If we have a add element of greater than the existing value. So these are the two problems like I have solved in this thing. Hope you share and subscribe my video.